You know, sometimes the universe gives us these incredible shapes. And this one, it's literally a giant Valentine, glowing red out in the cosmos. Today, we're going to dive deep and explore the absolutely wild story of what's happening inside the Heart Nebula. And wow, just look at it. This incredible structure, its official name is Sharpless 2190, by the way, is this massive cloud of glowing gas and dust. And get this, it's about 7,500 light years away. To put that into perspective, the light you're seeing right now left that nebula right around the time humans were first inventing writing. That's just mind-bending. You can find it up in the constellation Cassiopeia.
Okay, so we call it the Heart Nebula for, well, pretty obvious reasons, but astronomers, they've got a few different names for it. To really get what's happening inside, we gotta first figure out, what exactly is this thing? Let's trace its identity.
So this thing was first spotted way, way back in 1787 by the legend himself, William Herschel. But it wasn't until the 1950s, with the boom in radio astronomy, that it got cataloged as the super powerful radio source called Westerhout 4, or just W4 for short. Nowadays, we mostly just call it the Heart Nebula. But see that other name there, IC 1805? Remember that one. It's going to be super important because it points to what's at the very core of this whole story. The shape is cool and all, but what's really fascinating is what's happening on the inside. What's the engine that's making this whole thing light up so bright? Well, let's zoom in and take a look at the powerhouse. Okay, so here's the key. The nebula isn't just glowing by itself. Nope, it's being lit up from the inside, like a giant cosmic lantern. And the light source? It's a cluster of unbelievably hot, massive, and young stars. That's the engine. And remember that name I told you to remember? Yep, astronomers call this cluster IC 1805. This chart really gives you a feel for just how packed in that cluster is. Every single one of those dots is a star, and they're all squeezed together. But we're not talking about just any old stars here. A lot of these are O-type stars. Think of them as the rock stars of the universe. They're pretty much the hottest, brightest, and biggest stars you can get. Absolute cosmic giants. And here's the kicker. In cosmic terms, they're just babies. This whole cluster is only about 2.5 million years old. Now that sounds ancient to us, I know, but for a star, that's nothing. It's like the blink of an eye. And you know, just like babies, being young means they are full of energy, and their temper tantrums, yeah, they're on a galactic scale. So what happens when you stick a bunch of super energetic, massive baby stars inside a giant cloud of gas? Well, they do what babies do. They make a mess. They start carving the whole thing up, and the result is absolutely spectacular. The main tool they use for all this sculpting is something called stellar winds. The best way to think about it is like a constant, super high-speed hurricane of particles and radiation just blasting off the star's surface. Now imagine a whole cluster of these giant stars all doing that at the same time. You don't just get wind, you get a collective, unstoppable super wind. So here's how it goes down. Those stars in IC 1805 let loose their powerful winds. These winds basically act like a giant cosmic snowplow, just pushing all the surrounding gas and dust further and further out. What does this do? It carves out this huge, hot, empty space in the middle, a superbubble. And all that gas and dust it pushed away, it piles up into a dense shell around the edge. And that shell is what we actually see as the glowing Heart Nebula. And the crazy part is, scientists can actually model this whole thing with stunning accuracy. This image here, it comes from something called the Companids model. It's a theory that predicts exactly how a bubble like this ought to expand. And you'll notice, it's not a perfect sphere, right? It kind of stretches out, gets elongated as it pushes up and away from the denser parts of the galaxy. Okay, now this is where it gets really, really cool. On the left, you've got the model's prediction, that black outline, laid right over a map of the actual gas. And look at that, it's a perfect fit. It shows the empty space exactly where the bubble should have cleared everything out. Then on the right, it perfectly traces the glowing shell of the nebula itself. Theory meets reality, and it's a perfect match. I mean, that's just an amazing confirmation of the physics going on here. But this whole superbubble thing, it's not just some local neighborhood event. Oh no. This thing is so big, so powerful, that it's actually changing the structure of our entire galaxy. It's become a kind of cosmic vent. It's opened up a galactic chimney. Yeah, a galactic chimney. Because this bubble is so incredibly energetic, it has literally punched a hole right through the main disk of the Milky Way. Think of our galaxy like a flat pancake. This thing has blown a hole from the middle of the pancake straight up, allowing all this hot gas and energy to just vent out into the huge empty space above and below the galaxy, an area we call the galactic halo. And just to give you a sense of the scale here, which is frankly mind-boggling, the top of this bubble stretches over 800 light-years high. That's 246 parsecs if you're into those units. This isn't just a little puff of smoke. It's a colossal structure that is fundamentally changing its entire corner of the galaxy.
And this isn't just a theory. Researchers have totally confirmed it. There was this paper back in 2009 that described it as creating an energetical connection between the star cluster and the galactic corona. So what does that mean in plain English? It means it's a direct highway for energy. It connects the hustle and bustle of the galactic disk with the wide open space high above it.
Okay, so we've talked a lot about all this destructive power, right? Carving out a giant bubble, but this story has a twist, because the very same force that destroys is also a force of creation. Right on the edges of this expanding bubble, something brand new is starting to happen. They call this process triggered star formation. So as that expanding shell of gas plows into all the quiet gas clouds around it, it creates this massive shock wave. The shock wave slams into denser pockets of gas and squeezes them. I mean, really compresses them. Think of it like squeezing a sponge. Eventually, they get so dense that they just collapse under their own gravity and poof, they ignite as a whole new generation of stars. And that's exactly what scientists are seeing in the Heart Nebula. One study pointed out that star formation in what they call elephant trunk-like structures, which are just these really dense pillars of gas, is almost certainly being caused by the expanding bubble. It's amazing. The first generation of stars is literally giving birth to the next generation. And if you want proof, here's the smoking gun. This table shows actual young stars that they found right at the tips of those gas pillars. And check out their evolutionary stage, Class I. Now that's just the fancy science term for a protostar, which is the absolute earliest stage of a star's life. They're basically brand new stellar embryos found in the exact spot the theory predicts they would be. It's perfect. So let's pull back for a second and look at the big picture. The Heart Nebula isn't just some static, pretty picture in space. No way. It's a living, breathing portrait of how the cosmos works, a story of cosmic cycles. So let's break it down one more time. You've got the engine, the hot, young stars of IC 185. Their stellar winds create the bubble, carving out the whole region. That bubble gets so big it becomes the chimney, venting energy out into the galactic halo. And finally, the edge of that same bubble becomes the nursery, kicking off the birth of brand new stars. It's all one incredible, interconnected system. So you see, the Heart Nebula is so much more than just a pretty shape. It's a real, living example of a cosmic cycle, where one generation of stars directly creates the conditions for the next one to be born. It really makes you wonder, doesn't it? What other amazing new structures are being born right now, forged in the very heart of our galaxy?